So we have here our next example. So using the same data that we have from our previous examples, we're going to determine here for the required moment strength, yung M sub U. So ito yung solution natin. Since we have here a singly supported beam, so first, i-determine muna natin yung ating mga reactions dito sa ating mga supports. So to solve for the reactions, magsama lang tayo ng forces ano, Y to be equivalent to 0. So by symmetry, meron tayong dalawang forces going upwards, which are 2R. So which is now equivalent to, kung kukunin natin yung resultant force nitong uniform distributed load natin, this is equivalent to W times yung length ng ating beam. So after that, we're going to divide both sides of our equation here by 2. So therefore, yung ating reaction is equivalent to WL all over 2. So once we have the equation for our reaction, determine naman natin yung ating shear forces. So take note, by area method. So dito at point A, meron tayong reaction na WL all over 2. So simultaneously, mag-increase ito at a certain magnitude or instantaneously mag-increase ito ng magnitude na WL all over 2. After that, yung WL all over 2, babawasan natin ng area ng loading natin na W times L. So WL all over 2 minus WL. So we're going to cross multiply. So WL minus 2 times WL all over 2. So WL minus 2WL, magkakaroon tayo ng negative WL all over 2. So ito na ngayon yung ating shear at point P. And of course, yung location ng ating zero shear force, since symmetrical lang naman yung ating section, yung location ng zero force natin is located at a distance of L all over 2 from our point A. After nito, madetermine natin ngayon yung ating maximum moment. So yung moment natin dito at point A is 0. Diba? So to solve for our maximum moment here, kukunin natin yung area nitong triangle na to. So area ng triangle, di ba, 1/2 lang times itong magnitude na to, na WL all over 2, times yung distance na WL. So L times L, that is equivalent to L squared, then 2 times 2 times 2, that is equivalent to L. So that's why, for simply supported beam with uniformly distributed load, madederive natin, or this is a justification na yung maximum moment natin is equivalent to WL squared all over 8. Since madetermine natin yung maximum moment, we will now be able to substitute yung mga values ng ating uniformly distributed load, tsaka yung ating length. So MU, this is equivalent to WU. Ito yung factored na uniform distributed load from our load analysis sa previous na example, which is 37.8379 kilonewton per meter. Times yung L natin na 7.5, squared nyo na lang, then i-divide sa 8. So ito na ngayon yung ating answer. MU, this is now equivalent to 266.0477 kilonewton meter. Ito na ngayon ang gagamitin natin na critical na factor bending moment sa ating structural design.